Hello, everybody, and welcome back. We're looking at question 24 on our 2019 Gauss paper. There are many ways in which the list 0, 1, all the way up to 9 can be separated into groups. For example, the list could be separated into the four groups 0, 3, 4, 8, 1, 2, 3, 6 is a group, and then 5, 9 would be the fourth group. The sum of the numbers in each of these four groups is 15, 10, 6, and 14. Okay, that tracks. 1 plus 2 plus 7 is 10. In how many ways can the list be separated into at least two groups so that the sum of the numbers in each group is the same? Okay. So we need at least two groups, so apparently you can't just group them all together in one group. That's fine. But we could have two groups or three groups, or maybe there's a way to do it with four groups. Now, if we had four groups, if the sum is always the same, so maybe we call S the sum, and we had four groups, then the total sum of all the numbers in all the groups is 4S. Okay? But if you're adding up all the numbers in all the groups and all we've done is split these up, then this sum is going to be the sum of our 10 numbers here, which is 45. And you can work that out by hand, you can grab a calculator, or there are formulas to add up the first so many natural numbers. So 4, my number of groups, would need to be a factor of 45 here. Well, 4 doesn't divide 45. But we can do the same reasoning and say, oh, if I had G groups, each group, the sum of the numbers is S, adding up all the numbers in all the groups, you would get G copies of the sum S. GS would be equal to the sum of all the numbers. It would be 45. So G has to divide 45. So what number of groups could we have? Well, we could split it up into one group, except they said we need at least two. We could get 3 groups, 5 groups, 9 groups, 15 groups, 45 groups. Except we only have 10 numbers, so we can't have 15 or 45. But maybe we can split it up into 9 groups. Except with 10 numbers, imagine the groups that you might have. We've got 9 in one group and 8 in another group. What could I add with 8? Maybe you could put 1 in there and you'd get a sum of 9, but what could go with 0? You'd have to have 0, 1, and 8 just to equal 9. Or something similar, like 0, 2, and 7. And that would give me a sum of 9, and there's no way, already we've used 4 of our numbers in only 2 groups. There's no way you're going to make 7 other groups with only 6 numbers remaining. So, can't have 9 groups, although, in theory we've got enough numbers to do it. It's just the specific numbers won't work out. So that leaves 3 and 5. Now, if we had 3 in a group, what would the sum have to be? Well, everything would add up to 15. Each group would have a sum of 15. For 5, each group would have a sum of 9. So we'd have 5 groups, each one of them has a sum of 9. Okay, so it looks like we've got 2 cases to work with. So I'll take a look at these groups of 5 first. Now, what group could 9 go in? Well, let's just make a group. 9's got to go in a group, so we'll put 9 in a group. And how about 8? If the sum is supposed to be 9, you can't put 8 with 9, so 8's got to be in its own group. Right? How about 7? Well, 7 and 9 would be more than 9. 7 and 8 would be more than 9. So 7's got to have its own group. Similarly, 6 can't go with any of the others. 5 is too much. At least we'd be having a sum of 11 if you put it with the 6. And that's 5 groups already. When it comes to the 4, there is something the 4 can go. You can't place the 4 with the 9, because that would make 13, and that's more than the sum that we're allowed. But you can place the 4 with the 5. That gets me just a sum of 9. Nothing else can really be added to that group, except maybe 0. And just like 0 could be added over here, if it's not over here. But 0 is the only other thing that can go with the 9. Okay, how about 3? Well, can't go with the 7, 8, or 9, but it can go with the 6. 2 can go with the 7, and 8 and 1 can be paired up. How about 0? Well, as I said, 0 could go in any of these groups. So we've got choices for 0. 5 choices where to put 0. Okay? But everything else is sort of fixed. 5 and 4 have to go in a group if you're going to have 5 groups and a sum of 9. So there's 5 different splits based on just the 5 choices of which group 0 is added to. It can only be added to one group, but we've got 5 potential groups it can go into. And I suspect the same sort of trick will probably happen when we make our 3 groups. 0 could be added to any of them, because 0 doesn't change the sum. Okay? So we get 5 different splits when we've got 5 groups. What if we had 3 groups and everything adds up to 15? Okay, let's say 3 groups, sum is 15. So similarly, 9's got to go in a group at some point. Okay? 8 can't go with 9, so 8 gets its own group. Now when it comes to 7, 7 could go with 8. Okay? Or maybe it doesn't. Maybe 7 is in its own group. Okay? 6, well 6 could go with 9. And now both of these groups are sort of full. They've got 15. And 5, 4, 3, 2, and 1 would make up the rest. Okay? So that works, but there's more that we could have. Obviously, 9 and 8 have to go by themselves, and so this would give me 3 splits depending on where 0 goes. Okay? But is there another way to split this up? Maybe 7 is in its own group. So that's a possibility. Or actually, let's try and be very organized, because I feel like we're going to have a few cases to work with. Let's leave 7 here. What else did we do? So my choices were, where does 7 go, where does 6 go? And sort of the other numbers had to fill in the rest. So let's put 7 there again. We'll deal with 7 a little later. But let's say our most recent choice was where 6 goes. Can't go in the middle group. We thought maybe we'd put it here. Okay? But maybe I put it in this next group. Right? So I still have 5, 4, 3, 2, and 1 to place. Now 9 needs 6, and there's 2 ways to make 6. Oh no, there's 3 ways to make 6. You could have 9, 5, 1, 9, 4, 2, and 9, 3, 2, 1. The 8, 7 group was already completed. 6 is here regardless, and then basically the other numbers fill in the gaps. And because we know if you got 2 groups with a sum of 15, we don't have to worry about the last group. The other numbers just fill in their spots. So with 6 over here, we had 3 different ways to make this group. Let's just fill in the rest of the numbers. 5, 3, and 1, and then 5 and 4. Okay. Those are the only ways to make 6. Either you use the 5 and then you have to have the 1, or you don't use the 5, and then you've got to use the 4, but then that means you got to put the 2 with it. Or you use the 3, and then you have to have the 2 and the 1, because 5 and 4 are too big. Yeah, okay. And each of these, the 0 could be in any one of the 3 groups. So now we've got 12 different possibilities. So we either place the 6 over here, or the 6 goes into its new group. So now let's go back a further choice. Let's put 9 and 8 in their separate groups, but let's not put the 7 with the 8. You can't go with the 9, so the 7 has to form a new group. Now where can 6 go? Well, 6 can actually go in any one of these 3 spots. Depending on how many cases, we might actually need another sheet, but we put the 6 here, or the 6 could go here, or the 6 could go here. Okay. Now, if the 6 is here, that one's complete. If the 6 is here, that's 14. You need to have the 1 go here. Otherwise, you're never going to get 15. And if the 6 goes here, well, you can't put the 1 in here, because then you'd need another 1 to make 15. So you're going to have the 2 go over here. Okay, so if 9, 8, and 7 are separated, the 6 sort of forces a certain completion on the others. Okay, So we'll place the 6. Now, where could the 5 go? Well, yeah, I think we're going to have to do some cases. So we'll move these to their own pages. So the 5 could go with the 8, or the 5 could go with the 7. And we'll move actually a little bit more down the page just in case there are some other splits that we're not seeing. But as I'm working through these cases, I want to draw attention to the fact, to the way I'm going through them, which is the way you probably should try and go through them, very organized. I'm counting down. Where does the 9 go? Where's the 8 go? 7, 6, 5, and I'm breaking off and looking at each case on its own. Okay, where can the 4 go? Well, the 4 can't go here, so the 4's got to go with the 7. 8 and 5 add up to 13. 3 can't go with it either. So now 7, 4, and 3 make 14. You're going to have the 1, and the 2 has to go here. Okay, so there weren't other cases with this, and so now we've got 15, 20 in total so far. What sort of numbers might we be expecting? 24, 26, so high 20s, looks like low 30s is a possibility as well. Okay. So how about down here? Place the 5 over here, that was a possibility. Where could the 4 go? Well, the 4 can't go over here, that would be a sum of 16. So the 4 has to go in here. And so now both of these add up to 12, they just need 3. So maybe the 3 goes here, or maybe the 3 goes here, and then the 2, 1 go in the other spot. So that's, and then the 0 can go in any position. So we get 3 more splits, 3 more splits. So that's 9, 21, 26. I think I saw 26 as one of the possibilities. Okay? So we definitely know 24 is out. 26 is what we're at right now, but remember there were other possibilities of where the 6 goes if the 9, 8, and 7 are split up. So we did 9, 6. Let's do 8, 6. And that was 8, 6, and the 1 had to go there. So now we ask ourselves, okay, where can the 5 go? Could the 5 go with the 9? Well, then you'd have 14, and you'd need a 1. But we already used the 1. So 5 can't go there. 5's got to go with the 7. So that makes a sum of 12. Okay. 4. Where could 4 go? Well, 4 can't go with the 12, so it's got to go with the 9. So that makes 13. 3 can't go with that, so it's got to go 2, and it's got to go 3. That's 3 more cases, so we're up to 29. 26 and 27 are out. Could be 29, could be 32. It's a question of, do we actually get another case? Because that sort of filled itself in with no other choices for us. So suppose the 7 and the 6 go together, we said the 2 has to go there. Okay, where can the 5 go? The 5 could go with the 9, and then you'd get the 1 would have to go with it. And that would force the 4 and the 3 here, so that's fine. Or could the 5 go with the 8? And since we're already up to 32, I'm willing to bet the answer here is no, but why? Why can't the 5 go with the 8? Well, that sums up to 13. You can't put 2 1s in there, so you need the 2, but the 2 is already in use. So we're not going to get anything there. And that is a sum of 32. So our answer should be E. Let's just double check. 3, 3. That's 15, 27, 32. There we go. So all done. And we just had to very slowly, very methodically go through the cases. And I think we have exhausted everything. The different possibilities of where the 6 can go. So even though we reached the highest number that we could have, so we know it has to be the answer, we have also reached the end of our casework. So we, even if it weren't multiple choice, we know it's only going to be 32. Okay, a nice little question, a little long in terms of the casework. I think if you were disorganized, but I think that went fairly smoothly. And so we can now move on to our last question, question number 25. I'll see you for that shortly.